Memory devices and digital integrated circuits. So first is memory hierarchy. So here we have two types of memory. One is auxiliary memory, the other one is primary memory. Auxiliary memory is also called as secondary memory. Primary memory is nothing but inbuilt memory, and we have ordered the all the memories in terms of increasing order of access time ratio. So computer memory is of two types. One is primary memory, the other one is secondary memory. Primary memory is again categorized into two. One is RAM, the random access memory. The other one is ROM, read only memory. RAM is again classified as two types. One is SRAM, another one is DRAM. SRAM is static RAM, DRAM is dynamic RAM, and ROM is read only memory. It is also called as non volatile memory. Here ROM is divided into two types. One is programmable read only memory, the other one is electrically electrically erasable programmable read only memory, and erasable programmable read only memory. And in secondary memory, it is of five types, and these are like external memory. First one is hard disk drives, soft disk drives, compact disk, floppy disk, magnetic tapes. So primary memory. This is the main memory of the computer, and the CPU can directly read or write on this memory. It is fixed in the motherboard of the computer. So your primary memory is of two types. One is RAM and ROM. Read only memory. So information stored in the read only memory is permanent in nature, and it holds the data even if the system is switched off. It holds the starting instructions for the computer, and the ROM cannot be overwritten by the computer. It is also called as non-volatile memory, the memory from which we can only read but cannot write on it. The information is stored permanently in such memories during manufacture. A ROM stores such instructions as are required to start a computer when electricity is first turned on. This operation is referred to as bootstrap. ROM chips are not only used in the computer but also in the other electronic items like washing machines and microwave ovens. So here we have the block diagram of a ROM, and the input is k address input lines are given, and output is n data output lines are taken, and the ROM is m cross n ROM, and m is nothing but 2 power k, and ROM is again split up into four types, classified into four types. First one is masked ROM. Second one is programmable read-only memory. Third is erasable programmable read-only memory. And fourth one is electrically erasable and programmable read-only memory. MROM, masked ROM. These are the very first ROMs that were hardwired devices that contained a pre-programmed set of data or instructions. These kinds of ROMs are also known as masked ROMs. It utilizes the presence or absence of transistor connection at row or column junction to represent a 1 or 0. So, uh, we have in the figure we have E type MOSFET, which is also called as an enhancement mode MOSFET. So your E type MOSFET is connected to the row, and the row, and it stores the value of 0 in the column. Okay, so here the same connection is happening, but here the value stored here is 1. So enhancement mode MOSFET are used since the channels are not continuous, and the symbol is used in broken lines that indicates the discontinuous channel. Okay, see the symbols are broken here. So that indicates the discontinuous channel. This procedure is costly and used only for large quantity order. Second one is PROM, programmable read-only memory. So it is a read-only memory that can be modified only once by a user. The user buys a blank PROM and enters the desired contents using a PROM programmer. Inside the PROM chip, there are small fuses which are burnt open during programming. So these are the fuse links. So it can be programmed only once and it is not erasable. So the fuses in the prom are blown by application of high voltage pulses and to the device through a special pin. A blown fuse defines as a binary 0 state and the fuse which is intact gives a binary 1 state. All the procedures for programming ROMs are hardware procedures. Even though the word programming is used, once programmed, a fixed pattern is permanent and it cannot be altered. And here your programmable read-only memory uses a p-channel depletion mode MOSFET. The procedure allows the user to program the PROM in the lab to achieve the desired relationship between the input address and the stored words. Special instruments called as PROM programmers are available commercially to facilitate the procedure. Once programmed, PROM is fixed and cannot be changed. If the pattern is to be changed, the unit has to be discarded. So next one is EEPROM, erasable, programmable, read-only memory. So the EEPROM can be erased by exposing it to the UV light for duration of up to 40 minutes. Usually an EEPROM eraser achieves this function. During programming, an electrical charge is trapped in an insulated gate region. The charge is retained for more than 10 years because the charge has no leakage path. For erasing this charge, the UV light is passed through a quartz crystal window. This exposure to UV light dissipates the charge. During normal use, the quartz lid is sealed with a sticker. And EEPROM, when it is placed under the special UV light, so what happens? The short wave radiation discharges the internal floating gates that serve as a programmed connection. The only thing is EEPROM cannot erase the selective data, whereas the entire information will be lost, and it has to be reprogrammed. So next one is electrically erasable and programmable read-only memory. The EEPROM is programmed and erased electrically. It can be erased and reprogrammed up about 10,000 times. Both erasing and programming take place for about 4 to 10 milliseconds. In EEPROM, any location can be selectively erased and programmed. EEPROMs can be erased one bit at a time rather than erasing the entire chip. Hence, the process of reprogramming is flexibly but slow. So the erasing here is called a selective erasing, which is made at a register level, and it is erased with an electrical signal. Whereas here in EEPROM, the erasing function is done by using a UV light. The advantages of EEPROM is that the device that can be erased without removing it from its socket. So next one is advantages. ROM advantages are it is easy to design and it provides the high speed and it is faster than MSI devices like programmable logic devices and field programmable gate arrays. The program that generates the ROM contents can be easily be structured to handle unusual or undefined cases. It is more economical. Disadvantages of ROM. For functions more than 20 inputs, a ROM based circuit is impractical because of the limit on ROM sizes that are available. It consumes more power and tends to run slower. So, from next class we will see RAM, random access memory. Thank you.